D-Day, October 29, 1965. D-Day, on one of the most remote and isolated segments of the entire United States. This steel building, now deserted, caps a slender shaft nearly half a mile deep. At the bottom is a nuclear device which in a few moments will detonate with a predicted yield of 80 kilotons. This is Project Long Shot. The operation site is Amchitka Island, close to the western end of the Aleutian Island chain. More precisely, it is about 2,250 kilometers southwest of Anchorage, Alaska, and some 800 east of the Kamchatka Peninsula. After World War II, Amchitka was largely forgotten. 160 square miles of barren tundra, bearing the scars and decaying installations left by the thousands of American GIs who served here during the war years. Then, Long Shot reawakened the island. Long Shot was an important experiment in the Velo uniform program which the Advanced Research Projects Agency has directed for the Department of Defense. The objective of Velo uniform is to increase the United States' capability to detect, identify, and locate underground nuclear detonations. The primary objective of Long Shot was to investigate possible travel time anomalies associated with seismic events occurring in island arc structures. Such anomalies could seriously affect the accuracy of locations made by long-range seismic measurements. Another objective was to compare the seismic signatures of man-made versus natural events occurring in such complex geologic structures. Amchitka was chosen for Long Shot for several important reasons. It is one of the most seismically active regions of the circum-Pacific island arc. Its geology appeared to be suitable for the experiment. Finally, it is the only uninhabited island in the Aleutian chain which has a usable harbor and also possesses an airstrip capable of meeting Long Shot requirements. Careful scientific studies of the island's geologic structure verified that an event of the desired substantial yield could be fully contained and would present no hazard to humans or to the wildlife population. The exploratory core drilling for this investigation of underlying strata was carried out during calendar 1964. The findings indicated that there were no zones of significant permeability, that is, no channels, open faults, or major fractures. The nuclear explosive was positioned at a depth of 2,300 feet in the Long Shot shaft, well into a layer of andesite. This rock is more closely related to granite than to alluvium, tuff, or salt, the media in which most previous underground nuclear shots have been fired in other areas. Above the andesite, the various layers were predominantly volcanic breccias, with some siltstone, graywacke, and tuff admixtures. A combined cavity and chimney height of 940 feet was predicted, leaving 1,460 feet of rock between the chimney top and the surface. Milestones in the evolution of Project Long Shot were as follows. On 6 July 1965, installation of a 165-foot-high drill rig was completed. Later, a 6-foot diameter shaft had been drilled to a depth of 260 feet. At this point, the shaft diameter was reduced to 52 inches, and the drilling continued. It was completed on 15 September at a depth of 2,346 feet. The first joint of a 32-inch steel casing consisting of two 40-foot sections welded together was lowered to the bottom of the shaft on 17 September. 4 days later, on 21 September, the last joint was placed at the top of the shaft. On 23 September, cementing of the space between the casing and shaft wall was begun. The cement was poured in 400-foot stages with a 24-hour hardening period following each stage. This phase of the project was completed on 2 October. After cleaning and checking the hole, the drill rig was dismantled and removed. This was finished on 5 October. Erection of the technical building over the shaft entrance began immediately. The tech building was designed to provide working space and facilities for the team who assembled and placed and armed the device, and also to furnish protection from the elements during this critical time period. Completion date was 10 October. On 14 October, the nuclear device was flown in from Los Alamos, New Mexico, and taken to the tech building for preparation and emplacement. As soon as assembly and final checkout were accomplished, the device, mounted inside this container, was ready. It was lowered into the Long Shot shaft on 17 October. Attached to the electronic and suspension cables of the device were a series of slifer cables and time-of-arrival gauges to record shock wave progress within the shaft. Following this, stemming operations in the shaft were started on 18 October. Stemming involved filling the shaft with alternating layers of gravel and a sand-bentonite mixture. During stemming, 10-foot expanding cement plugs were placed at the 700-foot and 30-foot levels, and a 10-foot plastic plug was placed near the surface. This phase was completed on 26 October. All that remained were a series of dry runs and a final check of the timing and firing circuitry linking the device to the tech building, to the command post, and to the recording trailers and on-site instrument stations. In addition to items already discussed, the close-in measurement program included 7 surface stations containing velocity gauges to record earth motion at varying distances from ground zero. 3 offshore stations were used to measure overpressures in water at a depth of 60 feet. These underwater stations were composed of self-leveling velocity meters, pressure gauges sealed in canisters, and 4 ball crusher gauges attached to each of the canisters. All were mounted either on a 3,600-pound block of concrete used to anchor each station, or on the cable leading up to the marker buoy for each station. In June of 1965, 12 downhole stations containing vertical velocity gauges and accelerometers were placed in the shafts produced by the early exploratory drilling program. These gauges measured ground shock to determine the efficiency of explosive energy coupling to the earth. The major instrumentation effort on Long Shot was embodied in the Long-Range Seismic Measurement Program. Participating in the program in Alaska were 3 major permanent seismograph stations and a number of temporary portable stations. In Canada, recordings were made by the Canadian Seismological Network and by temporary Vela uniform portable stations installed and operated by U.S. personnel. Southward in the United States, recordings were made by LASA, the Large Aperture Seismic Array in Montana, by the 5 Vela uniform observatories, by the U.S. Coast and Geodetic Survey stations of the Worldwide Network, and by Vela uniform portable stations and a number of university stations. In other portions of the globe, additional recordings were obtained by a majority of the Worldwide Standard Seismograph Network stations at favorable epicentral distances from the event, and by a number of other stations not affiliated with the network. This long-range measurement program was the heart of the Long Shot project. During final preparations for the shot, 3 concentric rings of remote air monitors and 2 of air samplers were mounted around the zero area. Their function was to detect and measure any faint trace of radioactivity that might seep or vent from the buried explosion, though no such effect was anticipated. Additional air sampling stations were operated along the Aleutian chain and in mainland Alaska. On the 29th of October, at 20:59 hours, the countdown for Long Shot reached -1 minute. As is customary for any nuclear event in any area, the island site was evacuated except for key parties. Among the aircraft airborne at shot time were H-21s, C-54s, and P-3s, orbiting to handle photography, surveillance, and other routine test requirements. At 1100 hours, the Long Shot device was detonated 2,300 feet below the surface of the island. Within milliseconds, the shock wave drove spray into the air from surface ponds. At Wairika, California, 4,464 kilometers from Amchitka, the first motion was recorded at 7 minutes and 37.9 seconds after zero time, which was at 2100 Zulu hours. The recording is here played back at twice the real-time speed. An average derived from body wave recordings at many stations gave a magnitude of 6.0 on the Richter scale for the Long Shot event. On Amchitka, there were few visible indications of the power of the detonation. Sensitive hand instruments of rad-safe men in a re-entry party verified remote monitor readings, finding no evidence of radioactivity above background level. Minor cracks appeared in the road fill up to a distance of 7,000 feet. No trace of abnormal radioactivity was detected from any of these shallow fissures. Very little damage was noted to any island installations, including even the tech building at surface zero. Extensive surveys detected no damage to wildlife on or in the water surrounding Amchitka. The sea otters were unharmed. Close-in instrumentation functioned well. The great mass of data derived from temporary and permanent seismic stations around the world, after reduction and analysis, will provide a much firmer base for interpretation of seismic events in the Pacific Island Arc structures. Long Shot was a highly successful project in the Vela Uniform Program of the Advanced Research Projects Agency.
Público.